My name is Nalin Agrawal. I head the sales engineering for India and SAARC region for Dynatrace India. Today's, I've been in the industry for last 18 years, as already mentioned by Pranav, but in Dynatrace, I've been there for last 11 years. And observability, I've seen it from the days when it used to be monitoring. And from last 11 years, I've seen how applications have transformed, the processes around it have transformed, how various business have transformed on which on these applications are there. And some of those things you will be able to see in my session as well. So let's start with it. In this session, I will be taking you through the Dynatrace platform. Then we'll have a quick quiz. And then we will be going deeper into the cloud related aspects, that what are the challenges, how they are different from traditional world, what is the complexity which Dynatrace is able to help you solve in terms of multi-cloud environment. Some of the very key use cases which we have seen or I have been able to help customers with in solving when they were doing a migration, whether it is a insurance company or it is a bank or it is a retail. I've seen multiple types of customers, including manufacturing companies and pharma companies as well. And these companies, when they were transforming, they had a lot of issues and we were able to help and support them to overcome these areas. And then lastly, we'll again have a quick quiz and we'll have questions after that. Starting with platform overview. So Dynatrace as a platform is focused on three aspects. One is observability. Second is your entire ecosystem where your applications are running, and the key focus on the business which you are delivering through those applications. But with these digital services, our key focus of having Dynatrace in the middle is to allow automation. That's the key area. And we will see what kind of automation you can expect when you have Dynatrace. As I mentioned, I've seen multiple types of applications and environments over the years. So starting 2006, where we had Dynatrace, applications were much simpler. There was SOA, which was being adopted. And that was one of the most complex layers which used to be there. At that time, collecting the data from various layers were very critical because you wanted visibility. So that's where this is what was important. As we moved ahead and the year came 2014, just data collection was not critical, but you really wanted answers to solve the problems. So collecting the data, that's where the practices of AI, ML came into existence. People started to extract it, and Dynatrace also included artificial intelligence into it. And it started to collect the data, which pinpointed that where is the problem, who is responsible for it. Moving further on that, now in year 2022, just having the answers is not enough, but we need automation. And the reason of that is because the applications have become very complex, and the environment underlying infrastructure is very complex. It's not just sitting in one data centers, but you have data centers around the world. Businesses are expanding very fast, and your applications are no more those simple traditional applications residing in one data center, having a simple DR on the other side. Every 6 months, you come up and bring a change in your environment. It's very dynamic. All right, so this where now the focus in the year 2022 for Dynatrace is, along with the answer, what automation can I bring in? At what level can we bring in these automations? So in these subsequent slides, we will see how the 4 areas are completely covered by Dynatrace, which first is observability. Second is AI intelligence, application security, and automation. The secret sauce, there are 5 key components of Dynatrace, and we'll be looking at each one of these key components in the subsequent slides. First one being one agent. How may ever complex be your environment, and how may ever wherever your application is running, whether it is any of the public cloud like AWS, Google, Azure, or you may be running a combination of apps. Like many of the banks I've seen that internet banking they are running in Azure or AWS, and then they have a middleware which is running on-premise uh, Kubernetes version, and there they are running their middleware, and then they are connecting to all the various backend services like core banking or multiple applications. And very similar kind of architecture is being adopted by multiple companies where they are running some services, front-end services in public cloud, and then they are running some services in the backend so that their data can be completely secure. In all these kind of environments, if I say that for everything you need a separate expertise, it becomes complex. That's why Dynatrace designed one agent for whatever and wherever you are running. And the advantage of this comes is that you are able to actually see Dynatrace, able to monitor. This is one example from one of our largest insurers that we were able to monitor their 18,000 servers in just 3.5 hours. Because all we had to do is just push the one agent to all their systems, whether it is Kubernetes, whether it is traditional infrastructure as a service, platform as a service, function as a service. So whatever they were using, we were just able to push those and able to discover all of these components. So this is the value add of having one agent with absolutely no configuration required. The second thing is, once the agent is in place, it starts to discover all the transactions, and that's called as traces, the metrics, the logs, and along with that, it pulls in a lot of data which is related to how the applications are interconnected to the various processes, the underlying hosts, the various data centers. Along with that, it pulls a lot of metadata, things like tags from your public cloud, things like the JVM arguments you're passing, the libraries which are getting loaded. There's a lot of metadata which gets collected. And then it builds that topology and helps us analyze the behavior. This ability to trace the transaction across multiple layers through the one agents is called as pure path. So this is a this is a patented approach from Dynatrace, which has been there for a very long time with Dynatrace. This same feature is where now Dynatrace is investing into open source world like open telemetry and working in conjunction with multiple large organizations like Google, Microsoft, etc. And we are giving our knowledge to those open source projects. With this data already built in across the various layers, the topology gets built. That is called as SmartScale. So in today's world, where services can go up and down in just a matter of time, you have auto scaling and many other features. You cannot be building these flows manually. That's why Dynatrace is able to build these flows automatically across the layers, across data centers. So if you have an application running in public cloud, entering into a private cloud, Dynatrace will trace a transaction and then build this virtual view for us. So this is called as SmartScale. This is the third capability as of the platform. Once this topo has been built, the AI and ML comes into play, which basically the Dynatrace at the backend is using explainable AI. There are multiple types of AI, but this is what we chose because this also allows us to know why that particular root cause was identified by Dynatrace. So this is very valuable information which the people get. That it just not tells you that there is a problem in the system. This is how the alerts are generated. It is helping us understand there is a problem in the application. It is impacting 176 users as of point of time. Then it is basically help understand that these applications are having a baseline data. We can see that there's a big change happening, and it gives us the real root cause of the problem, which is why that problem is happening, who is responsible for it. So with all this put in data together, the explainable AI allows us to go back in time and analyze what started it. So you can always go back and see where we can see that there's a deployment event happened. We have named this AI as Davis. All right. So this Davis is the name of the AI which we use. So that is very critical that we have this AI in the heart of the platform. Once this root cause is available to us, what do I do with this? how do I do the next step of it? That's where the integrations come into play. Dynatrace has ready integrations with multiple options like ServiceNow, BMC Remedy, etc. So that's how we are able to integrate this data with, and then we can also integrate with your Jira system and other systems, ticketing system, so that we can get a change management system, so that we can get real-time feeds. You can see that there was a deployment change. Just after that, the check destination started to behave abnormally. For this, a problem ticket was created in the ticket tool. Then someone started to work on that problem, and the action was taken to roll back the build, which was again the rollback action was again taken with the data from Dynatrace, and then a ticket was updated. At the same time, Dynatrace problem card was also updated. So it's a bi-directional integration which works all across, and this is fully automated. There is absolutely no manual configuration which is required. This is out of the box integration which is readily available with the platform. So with all these capabilities in a single platform, you have answers, and not just you have the answers with which you can design intelligent automation workflows. Now, what we have also seen is that when we are working with large banks in India, large insurance companies in India, some of the large pharmaceutical companies in India and manufacturing companies in India, they gone are the days for them when they were using single data center. They're having multiple data centers, and in each data center they have more than 4,000-5,000 servers. You can see single Dynatrace instance or cluster can monitor up to 90,000 servers. This is an existing case study for us from one of the largest retailers of the world, who is using Dynatrace to monitor 90,000 servers on a single cluster. So that's the power of the platform, that it allows us to auto discover all these components across multiple systems. That is where the scalability or hyperscale comes. And on that, the AI gets applied, it discovers, and topology and all these things happen. So what is the cloud observability walk? What we have realized is that in this changing world, when you move into the cloud world and you start adopting multi-cloud or multi-data center strategies, there are a lot of issues with it. And the old ways do not work, because these applications do not function like a monolithic app where you have a single web app DB and it connects and to the end user, etc. The second change is that these applications can change. The fastest change I have seen is with Amazon, wherein the application changes every 11 seconds. All right, so that is the speed of change which they are adopting to various requests they are getting. And then they are using a lot of different combination of multiple cloud services. So you may be using S3 buckets, you may be using data lakes, you may be using various kinds of functions. So all these things which you are using in the backend makes these applications more and more complex, and they are not the standard thing. So this way, if your observability or your monitoring or application perform approach is still the old way of doing things, or if your team, everything has to change in your environment with this. So that's a big change which happens when you move into this cloud world, and this is called as the hitting the wall. So in what used to happen in this traditional environment is, what we used to see is that people used to apply or capture data in silos. So they will use a log analytics tool to pull the logs related metrics. Then they might use multiple APM tools to pull in the application traces. And then they might set up various kinds of tools which will do an infrastructure monitoring and collect the various types of metrics. All right. And then with all these things, they will try to create some kind of alerting mechanism where what they want to basically do is create dashboards which will give us the visibility across multiple layers of your application. The second, and this goes on and on with every application you have in the system. But this requires a lot of manual instrumentation, and it was all about thresholding, and it requires everything in the eyeball analytics. With this, they added one more layer over this, which is basically a duct tape patch, where they say, okay, I'll apply artificial and I will apply machine learning, and then over that there'll be a logic which will do AI over it and try to get something out of that problems which the system is collecting. So it will take all the events from that system and then it will try to bring out something of that. This will again generate a little more intelligent alerts, but you still have a challenge in terms of finding the real root cause. With this fragmented data, which it has collected, we try to push the data in a service management. This is again a duct tape kind of traditional approach in which everything is extremely manual and you have so many different teams. Each layer has its own hardware, which is also adding a cost to the organization. And the whole idea of having this is, and this creates your ITSM workflow, in which how it used to happen is that when an incident occurs, the alert is seen by an L1 team, which is monitoring continuously all the dashboards and alerts. So this is a traditional approach which is existing. And then you have an L2 team who will analyze these alerts. So what L1 will say is that they will forward it to L2 team. L2 team will analyze it, see it, and then the L3 team will come into play, which might create a ticket for it, or maybe send it to a testing or whatever action they want to take. So in this whole process, it used to take a lot of time, and there will be multiple war rooms. And with this approach, it does not, basically the problem stays there. It doesn't solve. Customers are unhappy. Applications are not performing as required. So this challenge continues. So in this scenario, what our approach is what we want to highlight here is that for the complexity which is exploding, you have a high scale requirement, the change is accelerating, stakes are high, and again, I see this as a bigger challenge, that when you're trying to adopt newer technologies, the resources which you have are very limited. And you need to find resources, recruit them, and these guys are getting paid like anything today because this is the demand of the system. So with these challenges, what we really need is a completely automatic and intelligent observability platform like Dynatrace, which has ready integrations with service management or ITSM tickets. And this whole thing, whatever data is presented inside Dynatrace, is automatically pushed into service management. Things like all your user journeys, all your business services, which are discovered by the observability platform, are automatically pushed into things like ServiceNow. We have a ready-made integration with ServiceNow. So in ServiceNow, we don't need to do any kind of configuration. The configuration management becomes very simple because the entire topology is automatically discovered and presented here. Now, if that business service change, that change will automatically flow in here. Based on that, I can design my ITSM workflows saying if a problem exists, if an incident happens, how will these problems be resolved? And then you have this tracking mechanism in which you can design if something goes wrong, do I do a remedial action? Do I do some preventive action? Or I take it back to my testing team and or in my pre-prod, I solve those problems. So all of this happens automatically with Dynatrace. So Dynatrace is completely automatic. It is automatic root cause, automatic business impact analysis, and automatic intelligent orchestration. All these is part of the platform. With this, your incident management completely changes. So all the alerts are analyzed by Dynatrace, and then your L2 team comes into the play. This N2 team will say that if there is a problem which has already been identified, then the root cause is also identified. I already know the impact of this, that how many users are affected, how many business services are down. I already know who has to be informed for this. Then I can say the L2 team, which was earlier my L1 team, are doing a more intelligent task. They are writing automation playbook workflows than just simply sitting there or looking at dashboards. So they are writing intelligent workflows which can quickly resolve issues, like simple thing, log rotation, a particular device which has failed, restarting those services. These can be completely automated because Dynatrace has already given the root cause of it. With this information which is readily available to us, now I can design my workflows in a more efficient manner. If none of this works, then I hand it over to my stakeholders who will take it back into a pre-prod environment and try to test the application. False positive rate is somewhere around, the accuracy of Dynatrace AI is 97%. I have not seen unless, and that 3% is also because sometimes we are only monitoring part of the system and not the whole environment. That's why we always say you monitor your applications, the underlying infrastructure, and the surrounding components. Any kind of change management should also be integrated with Dynatrace. So when you put the whole ecosystem into Dynatrace, that's where the visibility of Dynatrace increases and the precision of AI to be able to pinpoint the root cause also increases. And that's where the L3 team comes. So this is completely transformed, and in many of the banks we are working, we have been able to completely transform the way they are actually doing their incident management today. These are some of the key use cases where I'm just highlighting few of them where we have been able to help our customers in terms of the various anti-patterns which existed, and we were able to detect and help them solve. The first one is tight coupling. This is very, very critical. When you are about to migrate your applications and you have your microservices, monolithic application, which you want to think that where should I break it? That's where Dynatrace is able to help us understand that these are various APIs of your monolithic application. And within that application, this particular service is 99% of the time talking to this service. So these services can be coupled together, even though they can be separate microservices, but they can be kept in the same container. On the other hand, there are other requests which are going to the other system, but they are not consistently being called. So those services can be decoupled and be kept in separate containers. These kind of important aspects of after you have done the lift and shift and you want to decide of which service to place in which containers and design your entire architecture is very, very critical. The other area of problem where we have been able to help is when you started with your migration and you created your various services, then you design your system, and in pre-prod, this is how it looked. When you ran all the test cases, very simple, very nice, as you had planned and programmed and designed, it appeared exactly the same way. But when it moved into the production, you realize suddenly the cost is booming because the number of services or the number of pods which got generated were too many. And it also had dependencies on third-party services, your caching layer, and all of this. So we have seen this happening. And then you realize that your traditional data center cost was much lower compared to the cost of your newer environment, because here, every service you use, you're getting charged more. So these kind of anti-patterns where your services, your design of the application is not appropriate. And you would quickly need to know where is it breaking, where is it causing a problem. So you can quickly search through these workflows. So what I can do is I can extract parameters from these microservices, and they will become my, those HTTP parameters or method arguments will become my filter. And based on those filters, all my business journeys, I can actually see the complete flow can be seen like this. And this could be across data centers. This could be across tiers, like in the initial ones, maybe microservices based in Azure. In the middle, you may have some traditional data center based application. In the backend, you might be using some data lake from some cloud provider, or you might be pulling in data from open telemetry. So this whole thing will be stitched together by Dynatrace, and a single view will be presented across these environments for Dynatrace. And that is where the value comes in, that you can quickly identify which one of my service is inefficient. This is another area where we were able to help one of our customers. Their logic was that basically this was a mobile app. What they wanted to do was that they wanted to quickly load all the places where this IFC codes. So what happens is when you're trying to do a bank transfer, you select all the which location of the bank is. So you select it via IFC log. So when you are selecting the IFC code, it has to load uh, all the banks and the IFC code of that. So the way the person had written the logic, based on the number the person was typing, that those numbers were asynchronously transferred. Like if I'm transferring via one of the bank and it starts with ABC, so ABC, I know the bank associated to it, so it automatically pulls the bank name. So that was the first recursion. Second thing is it tells the location, like it is in Mulund or Thane or in Delhi area or which area. So that is the second recursion. Third is it goes and builds the actual location of that branch where it is. So with every recursion, you can see there's calling too many number of times, wherein this logic could have been solved in just one single call. But now it is being called multiple times. This is adding to the threads. When the threads increase and the loads increase, the CPU increase. When the CPU increase, you might have written the logic, if the number of count increases of the CPU, then auto scaling should happen. When the auto scaling happens, too many containers got created. And then that creates another set of problems because your hardware resources are getting consumed now. Get a lot of problems in your application, and these kind of anti-patterns, which are at the design level, when they are written as a language, will be quickly understood. Many times when you're starting your diagnostics, you don't know where to start with. So you may have anything from where you may start. You may start from end user. You may start from your caching layer, web server, app server, proxy, database. Your area of diagnosis can start from any point. Because Dynatrace is able to pull all these components and dependencies together, wherever you may start, you can always backtrace and see that particular component was called by which other component, or what other dependencies are there on that particular service. So like you see here is journey service. Journey service is also associated to customer front end, is also associated to this .NET front end. All these are dependent services. So this kind of interdependency map is automatically built by the platform for each of your user journeys across the cloud environments out of the box. This is another kind of anti-pattern which exists in Dynatrace called as N+1. So when you have a monolithic code, it is very simple that you have a code service and then you're calling all the products for that code service. In a monolithic world, it works fantastic. But as you go microservices, it creates havoc. Because what will happen is, you can see here, one single request of a code service is making 4 different calls of product service, because each one is executing in a loop. So as they move in a loop, that is the number of times they appear on the screen. So one call makes 44 calls to the product service. And now if suddenly the load increases, let's say these are one of your aggregators, if you're part of insurance company, and that aggregator like most likely I've seen that 3 p.m. they suddenly start to push the load for whatever they have done in the morning. And that load, once it enters, suddenly at 3 p.m. you'll see that all your servers or systems are choked because the CPU is completely consumed. There is no memory in the system, and all you have to do is just restart the services. So these kind of problems exist because of the way the person coded it. Had he not put the object in the for loop, this problem wouldn't have been existing. So this is called as an N+1 call patterns, and similar to that, N+1 query patterns, in which we call the DB object in a loop or a if condition or a statement, wherein what the problems you will always see is that your thread pool, your database pool threads are completely consumed always, and when the load starts to come in. And because of that, and if you ask the database guys, you will realize that database guys, everything is green. There is no load. All the SQLs are taking very less amount of time. But here in the application, everything is waiting because there are no threads available from the database side. All right. So all your JDBC pools are exhausted, or ADO.NET pools are exhausted. These kind of issues happen just because the person called the object in the loop. Had he not called that, so this would have completely resolved the problem. So these kind of problem patterns exist, and the problems can happen. And we have already seen this in our environments as well. This is another example from one of the insurance company, wherein they were scanning a lot of documents. These documents had huge sizes. Now, what happens is that once it enters, the way they had written the logic was that the document gets scanned, and in every layer they were passing the whole file actually. So you can imagine that the first enters the 10 MB, that it increased to 18 MB, increased to 20 MB, and the overall 21 MB. Because of this, one, they had to assign a large amount of memory, which is your heap size was very large. So containers were not getting fit in. Second problem was the storage had to be very big. Servers had to be very huge. And the lift and shift was a very big problem, because asking for such high-end servers on a public cloud is extremely costly. Placing instead of placing the data in a disk drive, which is a magnetic drive, that is very costly compared to elastic drive, or if you're using maybe S3 buckets. S3 buckets is much more cheaper. So those kind of architectures could not be used, and you still have to go to a traditional architectures, because these was a lot of issues here. So when Dynatrace detected these problems, we said you only transfer the metadata, and you don't transfer everything from that application. That's where they changed their architecture. It worked superbly for them. The 69 MB per request, 69 MB size was down to 31 MB with this change. And this brought down a big requirements of their servers, and they could nicely fit in a container world, and microservices could manage that. This is another example from one of the system where, again, from the insurance industry again. In this case, the documents which are getting passed had to go through multiple layers. This was a workflow in which the documents were flowing. And at every layer, there was an encryption which was happening. So every layer was coming and doing, and this is the architecture that Dynatrace was able to discover. And this made, because every layer was doing the encryption, and there was a single instance of encryption, every call, like you can see, this is just one document call, resulting in 316 calls on the encryption. And when the load increases, there were few sessions which are getting timed out. So the person, what they had to do was, because they were getting timed out, they had to fill all the information in the document again. And this was very, very painful for all those guys who were trying to follow the workflow for this, because their sessions were completely timed out, and they got logged out from the session. So these kind of problems the Dynatrace is able to discover, and these issues we can help in detecting.